In this video, I'll be explaining about some of the fundamentals of SQL in general. And as you all know, this is one of the mandatory skill that every developer or tester or even a designer should be aware of. So I thought I'll handpick some of the important topics and make a video so that everybody gets benefited here. So we will also have some of the hands-on sessions on a couple of databases. We will see how to work with different languages. And along with that, while we are doing hands-on, I will also talk about some of the common interview questions and answers, and we will see how to write some of the common SQL queries as well. SQL is nothing but a structural query language, and this is one of the common language. So there is no database specific. This is just a common language that you can write across multiple databases. And of course, there could be a slightly, change in the syntax, the way you write in MySQL versus Oracle versus SQL Server. So there could be some minor differences. We will talk about those. But in general, SQL is a common language that can be written across multiple databases, right? So when we talk about the databases, here we're talking about here, four different, RDBMS technologies. I have just listed down four here, but there could be many. But I just listed down some of the widely used databases: MySQL, SQL Server, and Oracle and Postgres. So whatever we discuss throughout the video, you may relate to some of the feature that are common across the databases. So it's very important to start with some of the basic fundamentals and overview of the databases and some of the key concepts within the databases, right? And also we'll talk about the architecture and how it works, how the request is sent from the client, and how that is served from the server. So we'll talk about those, and we'll also talk about some of the data types that are very common in most of these databases, right? We will see how variables can be used in the programming, and also we will talk about some of the languages here. So there are set of languages that are, you might have heard the terms called DDLs, DMLs, DQLs, right? We will talk about those in detail. So let's start with the overview. So the relational databases, you take any of the databases, they're all called as RDBMS, Relational Database Management System. They are very appropriate for any online transaction processing. So for example, if you have a website to reserve a flight or banking transactions, so they're all called as OLTP systems. So for all those OLTP systems, for most, I would say for most of the online transaction systems, the backend would be one of the RDBMS, right? Is this the personal choice of choosing one of the databases? It could be various reasons for which we would pick one databases and build our transaction system. But end of the day, it is the RDBMS system that supports the data store. And you take any of the four databases here, they're all SQL based, right? You can write your structured query language in order to retrieve data or manipulate data on any of the databases, right? And these are some of the popular databases for accessing and retrieving, managing data, right? And also these are widely used in the industry along with PHP, Java, .NET, and there could be many tool set, but these are some of the widely used RDBMS in the sun industry. And these are very easy to learn because SQL is a common language, so it's very easy to learn, install, and develop applications through it. And also, some of the databases are open source. They are freely available under, GNU licenses. For example, MySQL is one such open source. You can use it. Even though Oracle supports MySQL, it is still open for community editions. So likewise, you have Oracle Express or SQL Server Express. There are several free editions are available for you to install and learn. So the continuation of overview. So most of these relational databases they allow database operations such as creating a table, adding rows, adding or removing columns, creating indexes for better performance. So all the databases support database operations, and you can have your data stored in the form of tables, and you can even set some of the keys. For example, primary keys, foreign keys, you can set those in order to make your data consistent across multiple tables, right? SQL provides those referential integrity keys feature, right? And also they allow updates to the table, indexes automatically whenever you do any operations on a particular table. You can write your own custom SQL queries to combine one or more tables and then retrieve data for any analytical processing, right? And also you can do multiple operations on multiple tables at a time so that you can retrieve meaningful data from the data store. So here is the architecture of the SQL. So most of the databases, RDBMS databases that are listed here, they all work on a client-server architecture. So what it means is you have a server which stores all the data. It will also have the server engine where it will take requests from external client and perform all the data manipulation and then send the response back. So let's say user is querying some of the table. The select query written on the client will be sent to the server, and the server will execute the query and then send back the response. So this client server both can be on a single machine as well. Even you can have a database installed on your local, and you using some SQL client, you can still write your query and gets executed within the same machine. But in a corporate or real-time projects, they will have separate server where the data is stored and processed, right? So this is all about the architecture of SQL in general. So what are some of the features of SQL, right? As I said, few SQLs are already some open source. They have a community edition which you can download and use it for your learning purpose or any standalone application standpoint, right? It is very secure and also speed in terms of processing. And when we say speed in terms of processing, we are just talking about OLTP systems, right? Some reservation, train reservation, or flight reservation. Those that require very minimal historical processing. So in those cases, it is very fast, and also it is very lightweight and heavily used with PHP or JavaScript or ASP.NET, right? So the reason we call it lightweight is you don't have to have powerful machines, and it's not like gigabytes of source code that you will be downloading and installing. They are especially when we talk about SQL Express or Oracle Express, which is also called as Apex. So they are very lightweight. You can download them and install them in just 10-15 minutes. And also most of these databases provide some community edition, so it is free and also work with multiple OS platforms. You can have it on Windows, Linux, or even Mac. So it supports multiple OS platforms. And also the SQL allows all the rollback, indexing, partitioning, so that you can write efficient queries and retrieve the data for high performance queries. Let's say you are writing a transaction wherein you are taking some customer information and then you are taking payment information, and if that payment doesn't go through, then you may want to just roll back the transaction, right? So it provides some of the procedural language features as well, so that you can club your transactions in a set of transactions, and If it fails, you can even do a rollback or commit. So based on the requirement, all the SQL features allow all rollbacks, commits, and also creating indexes and partitions. So let's look at some of the data types that are available in most of the databases here. Most of the SQLs you will find basic data type as numeric, which will help us save all the integers, small int, big int, double, decimal, with precision. So all those types are provided in most of the databases. And likewise, you have a date and time. You can have just the date part, date time part, time part. You can have in the date data type, and in the string data type is used to store some of the characters or a name or description, those type of information. Blob is another feature, a data type where you can actually store an object, right? Unlike int, date, or string, you can have the entire object stored into the blob, right? Even some of the databases provide a glob of JSON. You can have entire JSON saved in one particular column. I know Oracle supports that. You can have complete JSON XML also as a column in a database table, right? And also MySQL supports some of the geometrical locations, longitude, longitude. So those type of data will be stored into spatial data type. And we talked about JSON and XML already. So these are some of the very frequently used data types in most of the databases. So now look at the SQL variables. So in most of the databases, variables are used when you are writing any programs, right? Procedure or even multiple set of SQLs, right? So for all those, you can make use of variables so that you can set some value and then change that value of the variable throughout the execution of your program, right? So most of the databases provide this feature, and they're widely categorized as user-defined variable, local variable, and also system variables. User-defined ones are very user-specific, created by the users to perform some particular task on a data set. Local variables are variables that are local to that execution, and there will be some system variables such as date or date time format or some sort of manipulation variables are readily available in the system variables. So let's look at some of the variables examples. You can even use set command. I know MySQL supports this, and also SQL Server. You can declare some of the variables with some static value, and then later on, you manipulate and change the value based on the requirement. So here are some of the examples. You can even use set command and variable name equals to value. This can be a dynamic value or a static value as displayed here. And the idea is that there'll be a variable name and then the value, right? So this is how you can make use of variables. Even you can use a variable to set the value to come from a table. You can do that, and you can even do max of age from a student's table, right? And also you can say you can declare multiple variables along with some default values, right? So that is available. And also you can begin a transaction, you declare some of the variables and then you manipulate, right? And if you're talking about some of the system variables, so there is something called as wait timeout, or any timeout or any particular date format. Those can be used as some of the variables. So it really depends on the databases that we make use of. The idea stays the same. However, the syntax might be slightly different. So you may want to just revisit when you are working with particular database. So here is another important topic. Please pay attention here. SQL languages are something very common to most of the database, and the very first one is the data definition language. It is also called as DDL. They are nothing but the definition creation or altering or even dropping the table views or stored procedures or any other indexes. So all those creation and deletion altering, they're all called as data definition language, DDLs. Okay, and DMLs are nothing but data manipulation languages, wherein you will perform any insert of data, update of data, or even deletion of a record, or update certain value of a column. So all those are called as DML operations. Okay, so the next one is the data query language. This is where we will actually write the select command, select statement to retrieve one or more columns from a table, right? That's one of the major and widely used query language. You can even show and help from the database tables. And the next language is called a data control language. They're also called as DCL, using which you can actually grant permissions or revoke permissions for a particular schema or a particular user or a table. So you can actually set permissions at various levels. This is widely used in providing the user security. So if you want to have your users query only particular schema data or table level data, you can make use of DCL statements. So another language here is the data transaction language. They're also called as DTL. They are nothing but transaction control. You can use them in a particular transaction where earlier I was giving one example, right? If a customer is booking, he will provide the customer details first and then the payment details. And if a payment did not go through, you may want to just roll back that particular transaction. So in those scenarios, you will be using transaction, save point, commit or rollback based on the need of the operation. The SQL constraints are very useful in order to maintain data integrity of a particular table, and mostly they are applied when you are designing a database, creating table. So that's the right time you apply the constraints. And here are some of the constraints that I have listed down that are widely available in almost all the databases. Right, so let's talk about each one of those. The normal constraints is something which will never allow a null value to be inserted or updated for a particular column. Right, and the next one is the unique constraint. So this will not allow any repeating values to be entered. Either it can be an insert or update. It will not even allow repeating values, so that you prevent from duplicating your data. So primary key is a combination of both not null and unique. It will not even accept any null value, and also it has to be always different, right? It has to be unique. Whereas a unique constraints can accept null, but the primary key cannot accept nulls. And the next one is the foreign key. This is used when you are trying to set up relation between two different tables. For example, you have a employee table or a department table, and you want to make sure that each employee belongs to a table, department table. So that's when you make use of foreign key constraints, right? Check constraint is used when you want to satisfy a specific condition, and the default is used by default. You want to set any value to a particular column when the user is not entering any value for it, right? For example, if you want to set record insert date time to be default with the current system time. So what will happen if the user is not entering the value for the default column? The value for that column will be automatically coming from the system together. So moving on, we will talk about the SQL joins. These are one of the very important topic, and it will be used every single day for any developers, so please pay attention here. So there are several joins that are supported by most of the databases. The popular one is the inner join, but it's very important we understand all the different types of joins, right? So we'll talk about this with some examples, right? So the first one is called as self join. Basically, you use the same table to join again to find out something. For example, if you have an employee table and you have a designation of manager that you want to, if you want to bring out all the manager ID from the same employee table, then you make use of self join, and then figure out pulling the data from the same table. So in the left join, if you have two tables, table A and table B, the way it works with left join is all the records from A table will be picked up, and only the matching records from table B. Similarly, on the right join, you get all the records from table B, and then only the matching records from table A. To give an example here, let's say table A is something called as a city, and B, let's say the B table is your rank. So in this scenario, if you want to find out the count of rank students in each cities, then you would be using city as your left table, which is A, and B as your rank student. Right, in that scenario, every city may not have no rank student. Right, so you want to see all the list of cities, but only those that are matching rank student count from a particular city. So in that scenario, you make use of the left join, and this is most commonly used type of join than the right outer join. But the right outer join does the same, but the opposite of the left join. So if I were to take the same example, rank students versus the city. So if you want to know only the cities that are having rank students, so you will be using B table, which is the rank student table, as your right join along with the cities. So this will list down only the cities that have rank students. Right, it just depends on the scenario that you will be allowed to perform the task. So the next one is the inner join. This is one of the widely used inner join. So this will ensure that if you have a table A and B, it will bring out only those that are matching records. So for example, you can have employee as A table and department as B table. And if you want to know how many employees exist in each department, so in that case, you can make use of inner join based on the department ID for join between these two tables. So this will bring only the matching records from both the table, and your final aggregation will be carried over. And the next join is a cross join, and this is very rarely used, but there are certain scenarios where you want to find out the relationship between these two tables. In this join, what will happen is each record of table A will be joined with each table of record B. So if you have two records in table A and two records in table B, your output of cross join is always four records. So to give you an example, if you want to see the students that are taking up all subjects. So table A, the first record, first student might be taking all the subjects from subject table. So in those cases, you want to join from each of the table to each of the record in B table. So that is the scenario, and there could be many other scenario. I'm just throwing up some example for the sake of understanding here. And the last type of join is a full join. This is very straightforward. When you use a full join, you get all the records from table A and also records from table B. So to give you an example, table A could be a customer table, and B could be a reservation table, and there could be many flight. I mean, if you take an example of flight, there could be many reservation for which customer might not have booked at all, but there could be some customers they may not booked any flights at all. So if you want to get all the records in those scenario, you use the full join. All right, so moving on, we will have some hands-on session in which we will start with DDLs, DMLs, and DQLs. We will be creating a lot of tables, views, and we will do insert, update operations, and we will do some select operations using various clauses. You can wherein you can have multiple conditions, single condition. We will use some arithmetic, statements, and also we will make use of group by clauses and also order by. Right, so these are very useful, when you're trying to aggregate data at certain layer. So you can make use of various clauses. We will do those in the hands-on sessions, and we will also work with some of the views creation, index, and partitioning. And towards the end, we will also talk about various tricky SQL scenarios and interview Q&A. Probably I'll split this into multiple videos so that you can look at all the tricky scenarios in a separate videos. So before we start our hands-on session, it is important to have at least one of the database software installed on your machine. If you already have it, you can just skip it. Or if you want to know how do we install, I will have a separate video wherein in detail I'll explain how to download, set it up, and how to configure certain things and how to set up users and some of the common issues in a separate videos. But as a quick glance, what you can do is I'll show you for a couple of databases now. Let's head on to the Chrome. So when you search for MySQL download, you will have some recommendation from mysql.com. You can click on that. Once it is open, make sure you always download the community edition because this is one of the free software. Rest are all like an enterprise edition, right? So go ahead and click on this community downloads, and here you can make use of MySQL installer or a community server for your MySQL set it up, right? So this will also install the MySQL workbench. We will make use of that while we are doing for MySQL. And similarly, if you want to download SQL Server, you can head on to the Microsoft.com. So under that, you will find some options wherein it will talk about Express. The SQL Server 19 Express is the free edition. You can download this edition and get your database software up and running on your system. So once this is done, we will start our hands-on session.